Thank you very much. I would like to first thank the conference organizers for their invitation to speak. I would like to thank them for having the wonderful animation with the countdown. This is the first time I think I've ever spoken at a conference on time. It's usually just 60 seconds or 90, but when you have as many slides as I have, they matter. So let's get into it. What is a limiting case from the title of my talk? A limiting case is what happens when you get a series of options and take them all the way to their extreme. An example is a polygon of n sides. 3 is a triangle, 4 is a square, 5 is a pentagon. As n goes to infinity and those sides become smaller and smaller and more numerous, the shape becomes a circle. Thus, a circle is said to be the limiting case of the set of regular polygons. It's what happens if you take the idea to its extreme. I would like to argue, or describe, Python as a limiting case of C++. If you get all of the good ideas in C++ and simply clean them up by taking them to their extreme, I will argue that you naturally get Python as a result, just as the circle falls quite naturally out of the end of the series of polygons. I got interested in Python because in the 1990s I was undergoing a period, I will say, of divestment. I was getting tired of things. IRQs, for example. Anyone remember IRQs? Anyone remember IRQ jumpers? Anyone remember reading guides on how to make the IRQs on like your graphics card lower than on your disk so that your game's graphics would run faster? I got tired of malloching and freeing things around the same time that I stopped going in and setting the jumpers to manually tweak the IRQs on my machines. Both happened roughly around 1997. There's this point where you're new at things and you want to control all the knobs, and then some people remain fascinated forever with the knobs. I have a personality where I often, once I kind of get the point, am happy to have a machine take over some of the responsibilities of assigning IRQs. And I also was interested in a language, looking around in the late 90s, that would let me get on with the process of modeling a domain and solving problems in it, rather than worrying about where the computer had stashed my information in RAM. How could we simplify C++, but without repeating the sins of the old scripting languages? I don't know if you know any of them. Scripting language, I will just here define, for the purposes of this talk, as a language that takes the source as input. You give it the source and it maybe internally does a compilation step, but it goes ahead and runs it without, which means that as the program is running, the compiler is still there. Because you run the compiler, it loads the source, does something with it, and then starts it running. It's still there in the background, most famously in scripting languages, where most of them support eval, the ability to construct a string that wasn't there, that didn't exist maybe. You assemble it. It didn't exist when in the program source code, and you ask for it to be freshly evaluated, lexed and tokenized and compiled and run as an instance of the language. Python, just for fun, it doesn't have to. Most scripting languages don't. It also goes ahead and lets you get into the low-level tokenizer, make syntax highlighters really, really easy to write if you don't have to break the text into symbols. And it also lets you get into the ASTs, which makes certain kinds of linters extremely easy to write. A lot of the pieces of a language ecosystem that often you have to do without are built in Python. We'll talk about that a little later. So let's say we're going to build something from the ground up. What should we do with its syntax? We do not want to make the mistakes of some other scripting languages. I remember I was never able to use Perl. Can you see why? It's that $sign. I knew immediately that Perl didn't know how computer languages work. The reason that you put $signs when you say, echo $name, hello $user in bash, the reason the $sign is there is to mark $user as special somehow. because Bash also supports you just typing literal words, echo and hello. But once you make the grand Copernican revolution of entering real computer programming where strings live inside of little quotes and don't splay themselves out across your file, the privilege of being a real programming language is the $sign goes away. It's noise, it's ugly, it doesn't need to be there if there aren't other words that the variable names could be confused with. So I was never able to get started with Perl. If we're going to design a programming language that's for serious programming, we can't have little $signs. What are we going to do? Syntax? Let's use C's. I mean, it works pretty well, right? Let's have assignment be an equal sign. Wasn't what all languages chose, but people are used to it now. But let's not make it an expression. Let's not let people, many of these people will be scientists and school children. It's not always the school children that are worse programmers. It's going to be scientists and school children using a general purpose language. Let's not let them mutate state in the middle of an expression. Let's promote assignment to being a statement. If you're going to change the set of values you're currently working with, that deserves to be up at the top level so you can read down the left-hand column of a function and see when it adjusts the value of each of its variables. What should we use for equivalence if we've already used the equal sign for something that didn't mean equals? We'll do what C did. Everyone's used to that. Plus, minus, multiply, we'll just steal all of the bitwise and arithmetic operators because they work fine and everyone is happy with them. We will have a little bit of fun, of course. What do you think of when you think of the percent sign? You think of string interpolation, of course. It just so happens that the modulo operator had a vacancy. It wasn't defined on strings. So we will go ahead and build in string interpolation into any expression you want to use it in by using the percent sign. It will even be easy to remember. We will have numeric expressions in different bases work exactly like in C, because everyone understands C. Strings, we will use backslashes, just like C. Are you beginning to see the pattern? Control flow, what if we used if, else, while, break and continue? Fairly obvious meanings. Everyone's used to them. It will make the language easy to use. We will co-opt for to immediately be the iterator or range-based pattern that only has arrived in C++ more recently. But Python from the beginning had this syntax. For is what you use instead of a while loop to hide the math, the iteration, the linked list, or the incrementation used to deliver to you all of the items in a data structure whose details you don't need to know if the for loop, in talking with the data structure, is figuring out what to do. We will keep from C++ exceptions and exception handling that will make them vastly cheaper so they can be used as normal parts of processing. We will make item lookup a little fancier by supporting slicing, where instead of asking for one item, you can ask for a substring or a subpart of an array using a colon. And we will fix the original problem with C of the trailing comma. The story starts with Pascal, a horrible language that used semicolon not as a statement terminator, but as a statement separator. That meant that you had to put a semicolon at the end of every statement, but the last. It was a syntax error to put a semicolon on the last statement because it had no further statement to be separated from. That's the difference between a separator and a terminator, and it meant that whenever you tried to cut and paste and move lines around, your Pascal program turned into a syntax error. Until you went in and took the semicolon off the last line and put it on the one you've moved. KNRC, they were far better about statements, and they made semicolon a terminator, creating that beautiful symmetry where every single statement has a semicolon so you can move them around. Alas, then they dropped the ball. They made comma in static initializers a mere separator, which looks fine as long as everything fits on one line, looks quite normal, but as soon as your initializer gets tall enough that you switch it to vertical, you now have the same asymmetry problem from Pascal. Python was very early in making the, not the statement semicolon, but the comma data separator optional at the very end of the list if you want to include it for symmetry. Now, Python made it completely optional in either context. You can leave it off horizontally or vertically, or you can put it in horizontally or vertically. Completely up to you. It can make it easier, by the way, for a program to generate the text. You know, if you're doing code generation, it actually makes it easier to generate that top line if there's a comma after everything. This did later come into C99 and C++11, the optional comma. Interestingly enough, Go is very persnickety. Have any of you used Go? One person. Has it ever complained at you about something that you typed? Go actually doesn't make it optional. If everything fits on one line, it's illegal to have the trailing comma. If you switch things to vertical, it becomes mandatory. After all, I guess Rob Pike said, if it's a good idea, you should always do it. Another thing that we should bring over into the scripting language we're designing is namespaces. They're critical, they're crucial, they prevent the old nightmare of link time collisions of symbols that if you didn't write all of the libraries in question can be very difficult to resolve. But we're going to do it more simply. We're not going to let you arbitrarily name your namespaces. They will have the name of the file. If you write a file, foo.py, it is by definition a Python module, and the name of that module is foo. We're going to be even simpler. We're going to go down to only having one namespace operator. If I have a directory, my package, a file, my module, inside of which is a class and then it has some attributes, it is my package.mymodule.c.read, a universal operator which works on all namespaces, because after all, it's basically just busy work to have to remember to use different operators to do the same operation, looking in a namespace for a name. Don't worry, that doesn't mean in your Python programs that we're going to make you use the fully qualified name for a symbol like read. We will have several versions of the import statement that bring a module or a symbol in that module into your namespace that let you vary the amount of specificity, the amount of fully qualifiedness to the names, to wherever on the fully qualifiedness meter you want them. This means that automatically, without a single declaration, two load functions defined in different modules automatically are unable to ever collide. The fact that every module is its own global namespace, we call them module globals, means that static goes away. We don't need to there's no reason to be conservative and keep things out of that